All right, so if you go back to these problems, and we've already talked about these were in 7.2. And the first step that we had for these types of problems were look to rewrite each side or each exponent using the same base. Okay, so this is what we're looking to do first. So is that even possible with this problem, though? No, it's not possible. So if this is the case, okay, so if this can't be done, then what you need to do is follow these steps. Okay, you need to take the log of both sides of the equation. It doesn't matter if you take the common log or natural log. Okay? It doesn't really matter. What I would recommend, because the calculators you guys use have a key for ln that's easily accessible, and the log key is not quite so easy, or that may not work if you're not using the updated operating system. I would probably stick with ln unless you have an exponent with a base of 10. And then the log would probably be easier because it'll give you a numerical value to work with. Okay, but the first step in this would be, or the first step if it can't be written using the same base, would be to take the ln of both sides. Okay, so does everybody see what I did here? Is I just took the ln of each of these quantities. You're then going to apply the properties for logs. And namely, you're going to move the powers to the front of the expression. Okay, so we're going to take our x minus 2 and move that in front. And here we're going to take our 3x plus 2 and move that in front as well. Okay, so you're going to apply the properties of logs to move those powers out front. What we now have is an expression that has x in it, so we can start to manipulate the x's. And so the final thing to do here is to solve the resulting equation. Okay, so when we look at this equation now, we do need to get the x's out of these parentheses, so we're going to distribute the ln. So we get x ln of 6 minus 2 ln of 6. Distribute it here as well is set equal to 3x ln of 2 plus 2 ln of 2. So all I've done here is I've started to solve this resulting equation by distributing and getting rid of my grouping symbols. Now I'm going to combine my like terms. Since I'm solving for x, I need to get all the terms that contain x on one side of the equation. So I'll move them over to the left. So the x ln of 6 will stay. I'll subtract a 3x ln of 2 from both sides. That moves all my terms with the variable on the left. My 2 ln of 2 stays. And I'm going to add 2 ln of 6 to both sides. That moves all my constants to the right. Okay, once I get to this step, I now need to solve for this x. In order to solve for it and isolate it, I need to remove it from all the common terms. And so removing an x from each of these terms is called what? Factor. I remove that common factor or factor out an x, leaving an ln of 6 minus 3 ln of 2. And that's all equal to the stuff on the right doesn't change. And then my final step here will be to isolate x completely by dividing both sides by this whole expression, ln of 6 minus 3 ln of 2. Okay, those cancel, and I'm left with my value for x. And now, when you come across these problems on your homework, you'll use your calculator to evaluate this. Okay, so let me show you what that would look like. All right, so if you were entering this on your calculators, we'd enter everything in the numerator. So 2, the ln key is second x, so of 2, plus 2 ln 6. So I'm going to close off my entire numerator. So I put that whole numerator in a grouping symbol. I'm going to divide by, and I'm going to put my whole denominator in a grouping symbol as well. So ln of 6 minus 3 ln of 2. I'm going to put a decimal there inside so my display will give me a decimal. I also need to close off my entire denominator. Okay, and once I do this, I should get my solution, which in this case is negative 17.28 approximately. And that's my value for x.